So exercise which is related to simple magnetism MCQs. The chat is open. You will use the chat to answer. Don't bother about the wrong answer because your answer may be wrong, but I'll explain each of them. So the chat is open. Use the chat to answer. So there is a current in a wire. The direction of a current is out, means it's pointing towards you. So whenever, what kind of pattern? First thing, whenever a wire is carrying a current, a straight wire is there, so it will always produce a circular magnetic field. So C and D are totally incorrect. C and D cannot be an answer, which is not irrelevant to the question, the idea. So now it is carrying the current. As it is carrying the current out, so what kind of magnetic field pattern it should produce? Because it is the thumb, your thumb should point towards you. When it is carrying the current out, means your thumb is pointing towards you. If it is carrying the current in, the thumb should point towards the screen or towards the paper. So you will use a right hand grip rule here. You will use your right hand and your thumb should point in the direction of the current. So thumb should point outward. And your fingers will turn in the direction of the magnetic field for a right hand. So in what direction your fingers will turn? If your thumb is pointing towards you, your fingers will turn in anti-clockwise direction. So that's why B is the right answer. Is it clear, this one? If the current was into, then A should be the right answer. But because the current is out, that's why B is the right answer. Question 2. In which pair are both materials magnetic? So for this question, in which pair are the both materials magnetic? So when we check aluminum and copper, both are non-magnetic. Copper is a non-magnetic. Here iron, steel, both are magnetic. Here steel is magnetic, but aluminum is non-magnetic. That's why both materials magnetic in option C. The next question 3, a small compass is placed close to a strong bar magnet. Which diagram shows the direction in which the compass needle points? If you want to identify the direction of the compass needle, the simple way, draw the magnetic field lines from north to south. So when I draw from north to south, so this compass needle is not correct, it is the opposite. When I draw from north to south, this is also not in the manner. But when I draw from north to south, so compass needle is pointing in the manner. Why not D? Because when I draw the field lines, the compass needle is out from north and into south. So the field lines must point same as the direction of a magnetic field. If the compass, like when D will be right answer, if this compass was placed here, in that case D will be the right. Same way, if we place a compass here, how the compass needle will point? Out from north and into south. So it will point in this manner. If it is near the south, it will point in this manner. So a compass needle always point in the direction of a magnetic field. That's why option C is the right answer. Question 4. An electromagnet is used to remove a splinter from an iron. So if you are using an electromagnet, so means the material should be a magnetic material. What's the right answer? You can use the chat to answer this. So we use a magnetic, like we are using an electromagnet. So means the material must be a magnetic material. As I mentioned, don't bother about the wrong answer, as your class participation is important and you will learn from your mistakes. So if you are using an electromagnet, means the material must be a magnetic material. It cannot be aluminum. Aluminum is a non-magnetic material. It cannot be glass. It cannot be a wood. So iron C is the right answer. Means it is magnetic material can be removed by electromagnets, because electromagnet will attract the magnetic material. Here, this is a solenoid. A current in a coil produces a magnetic field. The magnitude of a potential means the voltage is changed here. So as you can see here, the magnetic field lines are pointing out from which direction we'll have a north pole, because the magnetic field lines are pointing out. So this is the north pole. This will be the south pole. The question is, what will happen if we increase the voltage of potential and reverses the direction of the voltage? Like first, left hand side is negative, right hand side is positive. Now what we are doing for a solenoid, they're saying if the right hand side will be negative and the left hand side is positive, what happened to the terminals? Like what happened to the polarities or the poles? And what happened to the strength of a magnetic field? What's your right answer? If we change the direction of the current, the direction of the poles will also change. So if you're increasing the voltage or a current, the strength of a magnetic field will also increase, like it will become stronger. So the lines become closer. So C and D are totally wrong. Lines become further means like strength is decreasing, but lines become closer means strength is increasing. So C and D cannot be a valid option. We are left with A and B. So what will happen if the magnitude of a potential we increase and we reverse the direction? So if we reverse the direction, so what will happen? North pole will be here, south pole will be here. And because we have increased the potential, so these field lines, the magnetic field lines will be closer to each other because it produces stronger magnetic field. As a result, these field lines become closer. So A will be the right answer. That line become closer means field lines will be closer, stronger magnetic field, and the right hand becomes the south pole, because if we change the direction of the current, the direction of the magnetic poles of an electromagnet or a solenoid will also change. Is it clear? Question 5. Okay. Moving on to the next question, question 6. Which statement about the direction of a magnetic field at a point is correct? Use the chat to answer this. So what is it? Which statement about the direction of a magnetic field is correct at any point? Look, the direction of a magnetic field is actually the direction of the force on the north pole. That, like example, if I have a magnet north and south pole, and we draw the magnetic field lines, we draw the magnetic field lines pointing out from north and into south. That's how we draw the magnetic field lines. So if I place a north pole here, if there is a north pole, where it will move away. If I place a north pole here, where it will move towards. So what is the direction of a magnetic field? The direction of a magnetic field is actually a direction of the force on the north pole at that point. Like which direction the north pole experience the force, that is the direction of a magnetic field. Same thing if I place a north pole here, where this north pole will move. We don't have a magnetic monopole, but what if we have a single north pole, where it will move? What will the direction of the motion of this north pole? So it will be towards the left or away. So that's why we say the direction of the magnetic field is out from north. And if I place a north pole here, which direction this north pole will move? It will move towards the south pole. So we say the direction of a magnetic field is towards, or so the idea is that the direction of a magnetic field is always a direction in which the north pole experience a force or the north pole start to move. Is it clear? So the direction of a magnetic field is the direction in which the north pole experience the force. Sorry. Question 7. In question 7, we have different materials are there. First material, we are passing a current. Second material, we are passing a current. The third material, we are passing a current. The first material does not attract the nails. The second material attracted. The third material also attracted. But when we switch off, there is no current. Still, there is no attraction towards the nails. For material Q, the attraction has, like it has demagnetized or it loses its magnetic property, but material R is still a magnet. So what is P, Q, and R? What could be a likely material P is made of Q and R? So P, because it is not behaving like a magnet when or an electromagnet when there's a current. So what is P? P should be a non-magnetic material. Where Q and R should be magnetic material, but Q should be a soft magnetic material and R should be a hard magnetic material. So Q should be a soft magnetic. Why? Because when there is a current, it was behaving like a magnet in the external magnetic field. When there is no current, it does not behave like a magnet. So P is a non-magnetic material. So which is a non-magnetic material? P is not behaving like a magnet. P is a non-magnetic material. So that is copper. Q and R are the magnetic material, but Q is a soft magnetic because it behaves like a magnet when there's a current, and when there's no current, it loses its magnetic property. And for R, it remain magnetized even though there is no current. That's why option A is the right answer. This question, the ends of a three metal rods are there, which are tested. And Q attracts and R. So means Q is attracting and R, and Q is attracting S. So it means what is rod 2? Rod 2 is not a magnet. Why? How we identify it's not a magnet? Because if it was a magnet, one side it should be attracted and one side it should be repelled. Because for a magnet, there are like one side of a magnet will have a north pole and other side it will be a south pole. So R is a magnetic material, but it is not a magnet, permanent magnet. So means rod 2 is not a permanent, it is a magnetic material, but it's not a permanent magnet. Then when we bring NQ to T, it is attracted, and NQ to U, it is repelled. So it means rod 1 and rod 2 both are magnets. Because the magnets can attract the magnetic material. So rod 1 is a magnet because one side it is attracting, the other side it is repelled. So rod 1 and rod 3 are the magnets. Rod 2 is not. How we identify rod 1 is a magnet? Because it is attracting the material. Like it is attracting the magnetic material, and one side for a permanent magnet, one side it is attracting and the other side it is repelling. That's why C is the right answer. Is it clear, this question, Sabin? Question 8, sorry. Any doubt in this, question 8? That how we identify that 1 and 3 are the magnets? Because the magnets always attract the magnetic material and the magnets, one side of the magnets, magnetic poles, they will like poles repel and unlike poles will attract. So rod 1 is attracting this rod 2, both sides. So this give an idea that this is a magnet and this is a magnetic material, but it's not a permanent magnet. But rod T, one side it is attract and one side it is repel. So this is also a magnet. So rod 1 and 3, because they are attracting and repelling each other, one side attracting, one side repelling, so means this is a permanent magnet. Iron nails are there. We have P, Q, and R. The question is, which material is a magnetic material? When we are passing a current in P, the nails are not attracted. When there is no current, the nails are not attracted. For Q, the nails are attracted and then not attracted. And for R, it is attracted and then it remain attracted. So the question is, which core metals are magnetic? This is related to a material. The question is, which are magnetic material? The question is not like which is a permanent magnet or which is a soft magnetic or a hard magnetic. That you don't have to classify. The question is, which materials are magnetic materials? Which are magnetic material? So when you pass the current in Q, Q was behaving like a magnet, and when you don't pass the current, it loses magnetic property. So what is Q? Q is a soft magnetic material. For P, it's not a magnetic material at all. And for R, when you pass the current and you don't pass the current, it behaves like a magnet. So R is a hard magnetic material. The question is, which core metals are magnetic? So you don't have to distinguish between hard and soft. So P is a magnetic material, Q is a magnetic material, and R is also a magnetic material. That's why D is the right answer. Is it clear? Because the question is not which is a hard magnetic or which is a soft magnetic or which is permanent or temporary. The question is which of the materials are magnetic. So soft magnetic and hard magnetic both are refers to magnetic materials. Any doubt in this question? And in question 10, two magnets are placed near a current carrying conductor. The diagram shows its experimental arrangement is there first. How the current will pass? The current will pass in this manner. Can you identify which side will be north and which is south? You have to use a right hand grip rule. Using a right hand rule, your fingers will turn in the direction of the current and your thumb should point in the direction of north. So which side is the north pole? Right or left? Which side appear to be a north pole? Your fingers will turn in the direction of the current and your thumb will point in the direction of the north. And use your right hand. Grip the wire in the direction. Yeah, that's right. So the right hand side is the north pole. So it means when you grip the wire, your right hand side will be north pole and the left hand side will be a south pole. And like poles of a magnet repel each other, so means this will move away, this will also move away. So both X and Y are repelled by the coil, so B will be the right answer. Is it clear, this question 10? How we work out which direction it will move? First, using a right hand grip rule, we identify the direction of the north pole and the south pole of a solenoid. Thumb is always pointing towards the south pole. So what we do for this one, thumb is always pointing toward the north pole of a magnet, not the south pole. So first, the current is passing in this manner for a solenoid. So this is the direction of the current. So your fingers for a right hand, you have to use your right hand rule. Your fingers will turn in the direction of the current and your thumb will point in the direction of the north pole. So when you grip this wire, your north pole will be here on the right hand side and the south pole will be on the left hand side. Here, like poles are facing each other, like poles of a magnet facing each other, so it will repel Y. And here south is facing south, so it will also repel X. So X and Y both are repelled by the coil. That's why B is the right answer.